Hello, we will go through an introduction to feature selection. So, what is a feature? These are attributes or variables containing information about the target. So, in this example, we can see that we have certain columns. The first one we can see, since it is an ID, so it is just an identifier column. Then we have this last one, which gives us information about whether a customer has purchased car or not. So this is the target variable or feature. And the others, the gender, age, income, and owns house. These are the features. When we look at this table, we see that the customer ID 103 has purchased a car while 105 has not. Because this target variable has a value y for customer ID 103 while it has a value no for 105. So this is the target variable or the variable of interest. The rest, gender, age, income, and owns house, so these features contain the information that is related to the target purchase car. So this entity given by the customer ID or the customer identified by this ID is described by these features. Okay, the gender is male, age is 47, income is 5 lakh, whatever it is per annum or it could be per month. Owns house, yes. So this customer having ID 103, is defined by these four features. And finally, we have the target variable value, which is yes. So this is what we mean by feature. We have seen examples in our previous videos as well. Now, another example, this is from a previous video. The link is here. We are having the information of 5 students. So this is the program they are enrolled in. These are the elective subjects and these are the hostels they reside in. So we have this in the first block, we have 3 columns for the 5 students. In the second block, we have 2 columns. The third one has been struck off, so we are not considering it, like we have removed this column. Now for the first block again, we create the distance matrix for the 5 the given students. So this is Amit, Manish. So this is the n cross n, and then the third one, then we have this Sneha, and the last is Venki. So this is the distance matrix. And similarly, after removing a column, we have again computed the distance matrix and we can see that values are different. See, the distance of Amit with Manish is 1 by 3 here, while it has increased when we remove a column. Okay, similar differences we can see here. This is reduced. Amit with Sneha was 2 by 3, but after removing the column, it becomes 1 by 2, so it has reduced. Similarly, at this position, this 1 by 3 becomes 0. So distance has become 0. So what do we see? By removing a feature column, distances change. So any conclusions based on distance measures will also change. So what did we see in these 2 slides? That we are having some data entities or some data points which are described by the features, and we see an example where we remove a feature and then compute the distances between the data points and the distances change. So removing a feature from a data set brings about changes, especially when we look at the distance change. So why do we remove a feature? Now we saw we removed a feature. It could be for several reasons. One is that smaller set of features means less computation. Suppose you had say features from F1 to F100, and now in the change scenario you are having F1 dash to F2 dash and say only F10 dash. So out of these 100 you brought it down to 10. So the computation is lesser, so it is smaller memory footprint and faster. In some applications, obtaining each feature or test results can be costly. So if we could remove certain features, or we could do without these features and still get the desired values of accuracy or prediction, then it would be good. Finally, with large number of features and less number of data points, we could have overfitting. Overfitting happens when the model is not generalizing and is kind of memorizing the data points. So it is not, it is giving very less error for the train data. That means train error is very less. It's just for recap, we have seen this earlier, is very less or maybe near zero, while the test error is very high. Is very high. That means no generalization. So we can see that feature selection is necessary. And what do we mean to achieve? We can maintain or improve accuracy. That means we, without loss of accuracy, we are doing with less features, or in some cases where overfitting would have occurred, or we had noisy features. Noisy features means irrelevant features, then we improve accuracy. And simplify classifier complexity by reducing the computations. So this is what we are aiming to achieve. The other thing which we would have heard of at several places is the curse of dimensionality. See, we have plotted here the classifier performance on the y-axis and number of features here on the x. So with the increase in number of features, the performance improves. However, at a certain threshold point, the performance falls down. So this is the, while the number of features have been increased. So this is also known as the curse of dimensionality. So that also we are trying to reduce by removing certain features. Now, for n features, we would have these many subsets. We have seen that feature selection is important, but we cannot go through all such subsets. So we could use heuristic methods, we could use randomized techniques, and the subset generated also has to be evaluated. So all these we would see in the future videos. So I hope you have got an idea of what is feature selection and why it is necessary. So thank you. Thanks for watching.